Welcome everyone, and thank you for signing up to this seminar on conditioning and quantifying seismic data for advanced reservoir characterization studies. My name is Arne Nordborg, and I am here today together with Gaston. Gaston is the product owner for the product we're going to present, and myself, I am the Global Business Development Manager for Cegal. I hope you're doing fine, despite the circumstances we experience today. And we're looking forward to these 30 minutes on reservoirs or SRC, our plugin from QUANTIFYING. The seminar will last for about 30 minutes. And the recording will be sent out 24 hours after the webinar and available on YouTube channels. For the Q&A part, feel free to ask any question in the chat on the GoToWebinar setup, and we will try to respond to as many of them as possible during the presentation. Cegal was founded back in 2000 and has since then, over 20 years, developed into a specialist in cloud and software for the oil and gas business. We have grown both through acquisitions and also through organic growth, being today a company with 420 employees and more than 13,500 users of our different products. We have, during this path, focused on building additional domain experience. One part has then, in that process, been acquiring the company Blueback Reservoir, that I'm sure quite a few of you are familiar with, which was a software and consultancy expert within the oil and gas domain. We have a global footprint. It's quite important for us in the sense that we have clients worldwide, and having clients worldwide meaning that we also need to support them in all our different locations. Our latest office opening was in KL late last year, where we now have a group of people supporting our client in the Southeast Asia, and not to forget the Australia region. Our setup is what we call a threefold setup, where we have 3 different areas we focus on: supporting the whole value chain within the E&P companies. This is our key, what we will focus on today, which is our software. We have a broad portfolio of software, standalone software, but also software directly linked to Petrol, which is one of the tools we will look at today. We also have a good consultancy group within geoscience, standard geoscience consultant, but also we do IT architecture, we do business consulting, looking at companies set up in that sense. And finally, our GeoCloud, which is the cloud solution for oil and gas business that is becoming quite important for our clients today when we have this situation with home office, where you can access from anywhere through the internet and work as of you're sitting in the office with access to everything through the solution there. I will now leave the table or the forum webinar to my colleague Gaston, who will be focusing on the SRC module, which is one of our geophysical tools available. So thank you, and I'll leave the table to you, Gaston.
Yeah, thank you, Arne, and good morning, everyone. It's a bit early today, but as we are possibly all still at home, it's not a big issue. Thanks for joining in about this technical session. So we're going to present or talk about our conditioning and quantifying module, which allow us to have a greater insight into advanced reservoir characterization studies. So let me just go into the matter right away. There's a lot of options and possibilities in this module, and we have been asked many times about a workflow, which is something I would like to discuss with you today. It looks like this, and it's a workflow that can carry us from the early conditioning of the partial angle stacks up to if you, for example, are interested in understanding thin reservoirs, then you would be running this seismic netpay, or the whole workflow can be a precursor to prepare and get all the data ready for Odyssey. Odyssey is our flagship inversion package, which it requires these type of preconditioned seismic data. Additionally, and this is not what we're going to discuss today, we have a very comprehensive rock physics package. So in terms of the workflow, the first thing you would like to start with is conditioning or partial angle stacks. We got several questions already as we have been running webinars all this time. My colleague in the UK, Lisa, has been presenting this in more detail. And we got many questions, like, for example, if we would handle directly pre-stack data. This is something we don't do. We work at the level of partial angle stacks. But then when you get these partial angle stacks, like in this example, you will have, for example, a near and a middle and a far. The classic, we can obviously handle more partial angle stacks than the three I'm showing in the example. What you want to do is estimate and correct for changes in rotation of the phase. So you want to get results at this stage that are very close to zero phase. You require this later on because you may want to run a color inversion, for example. Then you need to get rid of effects due to the angle of the increasing angle about losing spectral content. So you need to do a spectral balancing. And then there is sometimes in processing, there's parts left. We could call it noise, but it's important to align the horizons, special signals properly. So we have, we're looking exactly at the signals where they should be. And then lastly, there is an option to attempt to scale the data based on the reflectivity response coming from wells. The nice thing about this module is it allows you also to visualize AVO effects as you work on your conditioning. This is quite powerful. Then this gives you already early an insight. So just to show you very fast how this would look like in a Petrel. So I have a project here, and I have what we call a Blueback gather window, and here you see this traces grouped here. So everyone is a inline or crossline trace, but then you see three at every inline or crossline position, which meaning each trace corresponds to the corresponding partial angle stack location. So this would be the near, the mid, and the far. So this is now displayed without, so I have that run already a zero phase correction, but then I haven't done any spectral balancing or time alignment. All that information is kept in a virtual attribute mode in Petrel, as you see here. So when I turn for example, the process is on, and each process has its own interfaces and so on. And then I hit apply, then have a look at this part here. At the moment I hit apply, so there's going to be a small processing done in the virtual mode, and it's going to be changing. And that's the way it works. It's a very visual, interactive way. This whole app is completely integrated in the Petrel world, so there is no connection whatsoever with external data objects. Everything is happening inside the application. So coming back to our PowerPoint, then we go into the next step in the workflow. Once you have done your conditioning, the next is to compute intercept and gradient. For this, we have several options. The classic, or the mostly used in the industry, the Shuai approximation and the Fatty approximation and so on. Here you put again your partial angle stacks, and in increasing order. As I mentioned before, you don't need to have necessarily 3. This is what we usually get to have. But in real case scenarios, actually they can be way more, and the more you have, actually the better for these calculations. So this module returns to us intercept and gradient, for example. So once you have intercept and gradient, then you could go and either do an AVO classification. And for this, again, I would like to refer to a fantastic presentation done a few days ago by my colleague in the UK. And that video is available in YouTube, so you can look at it again and get into the details of how to run this AVO workflow in detail. But as we all know, AVO is one of the most traditional workflows in the industry. It can prove to be a very valuable tool. The nice thing about this implementation is very, very interactive, and as you work with it, it can give you quite very good insight into what is happening in terms of AVO response, the strength, and this using all virtual representations, so you don't need to wait and do something and wait a long time until you get some result. You can estimate the impact of applying or looking at AVO responses right away. So this is once we have done our AVO classification, well, it could be one of the end of the workflow for some cases. That's what you wanted to do, that's fine. In other cases, you may want to still move on and go for a different move on in the workflow. So once you've done your intercept and gradient, one possible option is to go and do color inversion. And again, here we've had another webinar on this topic, full detailed, showing all the options. What happens in color inversion is where we design and apply an operator based on the reflectivity response from the wells, and then we not only rotate the face of the seismic by 90 degrees, and again, this is why as an input it is important to use the zero phase seismic. It's important for the color inversion. It's demanding, so to say. And then we estimate the different parameters to get an operator that will allow us to color invert the data we want. And again, this is a very interactive process where you can fine-tune the operator using a virtual representation in Petrel, and start to see the detailed changes you do, especially in the lower part of the frequencies, where this makes a big impact. later on, you can have a very detailed insight in how your operator is going to act upon the input seismic. So once you've done this process, at the end of the result, you realize this and you get a color inverted result. You can also save all the operators. So then after having done this step, you get relative acoustic impedance, relative gradient impedance, for example. So then you would be ready to go into what we call the coordinate rotations. This is nothing else than computing and doing the so-called extended elastic impedance angle analysis. So this is where you would plot the acoustic impedance versus the gradient impedance. You build a cross plot and then you discriminate, and you can color code those with phases. And the idea is to find a rotation angle, a chi angle, projecting this in a different plane, and trying to get that division. So I have another example of this with Petrel, just to illustrate this. And again, referring back to my colleague, she's been doing and running this the last few days, also on a webinar. So again, we have all that information already available to you on our YouTube channel. But this is the way it looks like. This is, if you want, a detailed analysis tool where it allows you to use multiple wells if you want for the analysis. Here in this case, I have just selected one, but you could select any amount of wells you want. It works with multiple wells. Then options to define input data like top and base. Then you need to have your PVS and density data, calculate averages. The K parameter is very important in the equations for extended elastic impedance. And then you have another option to select color logs and the phases. The phases are important because we can color code everything by our phases. In this case, so we have all these main phases in this example. You could even turn some of these phases off or on if you don't want. And then, right, it's about moving this angle and estimating what happens. So in this case, I am using the gamma ray as a log for comparison, and then moving this angle, this chi angle projection updates all the displays interactively. New in the last version came the ability to compute, for example, semblance traces to help us understanding the correlation better. In semblance, you have a positive correlation when you have values around 1.0, and negative correlation when you have values very close to -1. So all these options allow us to estimate the best chi angle for the logs, and we use also the seismic as a comparison, as we discussed also in the previous presentation, and there were many questions about that. We will always find differences between the estimated chi angles using well data and the estimated chi angles using the corresponding in this case already color inverted gradient and acoustic impedance. This is due to many factors. One of them, obviously, that seismic has lots of other aspects. And we're talking about relative acoustic impedance here. There is noise and so on. But at the end, this is a very nice module and tool to estimate and analyze the impact of rotating these coordinates. Here you see already how I'm starting to split this distribution here of the histogram in two different parts. I'm just trying to, or starting to differentiate between these two types of lithologies. So back to our presentation, then once we've done this part with the coordinate rotations, we get relative acoustic impedance for many points. You can create a large set of different chi angle extended elastic impedance volumes, and this would be representing certain or highlighting certain phases in your seismic. We usually talk about the lithology cube or the fluid cube and so on. So one version might be highlighting some aspects of the phases than others. So, and that is one of the most important inputs for running our one-dimensional stochastic inversion. But in the sense of the presentation of today, in terms of the workflow, one of the final goals of this whole workflow is to get into the so-called seismic net pay, which again has been broadcasted a few days ago in greater detail. Here is where, and that applies in case you have a very thin reservoirs, and then you want to estimate the impact of the tuning in your data, which might be telling you or suggesting to you that you have a way more hydrocarbon in place than you actually have, that most of it might be actually tuning effects. So this method goes back to Pat Connolly in the early 2000s. They developed this, and in fact it's now one of the most used or standard types of workflow in the case of when you have very thin reservoirs. So you need to have a color inverted extended elastic impedance as input, and then it is very important to, and it has been stressed during the presentation made by my colleague, that is incredibly important not to do what you are seeing here, actually, that we have a sort of a problem in the picking of the horizons. They have to be very, very detailed and very accurately picked on the zero crossing. This is because you are building the band limited, the average of the band limited impedance between those zero crossings, and this is producing this plot. Wherever we have some noise or wrongly picked data, then you can get the results are not going to be as precise. So we use also the known frequency information to model a tuning wedge, and then you will try to adjust the data to this curve here. You see it's the same here, and try to understand the tuning of this area. So that's what happens in the NetPay. So with that, essentially this is what covered the whole workflow. As I mentioned, once you have all this, you can go into Odyssey, and I think at some point there's going to be also a Odyssey dedicated session to explain how this I would say fantastic inversion scheme towards rock properties and lithophases works. But with that, I would say, and we are almost on time, I would like to return the stage to Arne, saying what we have seen now is Blueback, the SDC SRC. We are in the version 4.4 with our SEISMIC data conditioning tool, and then where we have the delivery of reservoir characterization or seismic reservoir characterization with high-end geophysics assisting you. And so with that, thank you very much, Arne. The stage is yours. I don't know if you are muted, Arne, but I don't hear you.
I am certainly muted. So, well, thank you very much, Gaston, for your presentation. And unless there are any questions, I suggest that we end the webinar now. I want to thank you all for participating. And if there are any questions afterward, feel free to contact our support, or you can contact at webinar@cegal.com. And as mentioned, all the webinars will be on our YouTube channel or on our webinar series for your playthrough at the later stage. Well, thank you very much and have a great day.